In this exercise, we're going to pretend that the year is 2006 and that we've just purchased a brand new 2006 Honda Accord. The suggested price is $20,025, and we're told the car is going to lose $1,385 in value each year. We're asked to complete the following table in which V represents the value of the car after N years of ownership. I just want to point out, if it's currently 2006, a car that's 8 years old would be a 1998 model. A car that's 3 years old would be a 2003 model, and a brand new car would be the 2006 model. So the value of the car, if it's brand new, well, we're told that's $20,025. So we can put that here. To determine the value for a car that's 1 year of age, well, we're going to subtract the depreciation because it's going to lose $1,385 for each year. So if I take out my calculator, I can actually subtract $20,025 minus $1,385, and I get $18,640. So I'm going to place that on my table. If I wanted to determine the value of a car that's 2 years old, well, I'll subtract my depreciation amount one more time from the $18,640 to get the next value. So I can say $18,640 minus $1,385, I get $17,255. To determine the value of the 2003 car, I have to subtract that $1,385 one more time, and I come up with a value of $15,870. Now, to determine the value of the 2001 car, I actually have to subtract this $1,385 two times because we're going from years 3, 4 to 5. So it's going to depreciate two times because there's 2 years in between 2003 and 2001. So I'll have to subtract two times this $1,385. When I perform the subtraction twice, you'll see I'm left with $13,100. And for my last calculation, to go from years 2001 to 1998, there's 3 years in between. So I'll have to subtract this $1,385 three times from this $13,100. So if you look at my calculator, you can see I've subtracted $1,385 three times to end up with this $8,945 value. So now that my table is complete, let's move on to some questions. Question B says, is the value of a car a function of the number of years of ownership? Explain. Well, remember the definition of the function says that for each input there must be only one output, right? So each input has no more than one output. So when I look, my input in this case is the age of the car, and my output is the value of the car. So again, I guess I'm going to say for each year of ownership, there's really only one value of the car. You see, if I own the car for 2 years, the value of the car is $17,255. I don't have more than one value for 2 years of ownership. And for 5 years of ownership, the value of the car is $13,100. I only have one value for this particular input. So again, going back to the definition of the function, each input only has one output. We know we have a function. In terms of the input, again, we're going to say the age of the car is the input and the value of the car is the output. Next, we're asked to select two ordered pairs from the table, and we're asked to determine the average rate of change. So we remember that the average rate of change is the change in output over the change in input. So the two ordered pairs I pick correspond with the age of the car being 0 and the value $20,025, and the car that's 1 year of age and the value being $18,640. So I wrote the ordered pairs down here, and now I'm going to do my change in output over change in input calculation to determine the average rate of change. So after I perform my calculation, I'm left with negative $1,385 per year. We're then asked, what are the units of measure of the average rate of change? That's going to be dollars per year. What is the practical meaning of the sign of the average rate of change? Well, the negative sign indicates that the car's losing $1,385 per year. If it was a positive sign, the car would be gaining value. Very few cars actually gain value. Maybe some exotic Ferrari or some rare Lamborghini gains value over time. But for the most part, cars lose value over time, so that average rate of change will be negative. So the sign really just indicates the direction of the change. Is the change going up or down? The next question has us select two different ordered pairs, and they're asking us to compute the average rate of change again. So we'll pick another two pairs. So I'm going to pick the ordered pairs that correspond to the years 2001 and 1998. So that would be 5, 13,100 and 8, 8,945. So after selecting our ordered pairs and doing the algebra, we're left with negative $1,385 per year. So we've taken two different sets of ordered pairs and we ended up with the same result. Our average rate of change was negative $1,385 per year. Part E is going to have us do this exercise one more time. So we're going to pick yet one more pair, two more ordered pairs, and we're going to compute the average rate of change again. So the ordered pairs that I plan to pick will correspond to years 2004 and 2003, and we'll perform our calculation one more time. So again, when we perform our change of output over change of input calculation, we're left with negative $1,385 per year. So every time we took two different ordered pairs, we ended up with the same average rate of change. This is significant. Part F says, using the results in parts A, D, and E, what can you infer about the average rate of change over any time interval? Well, if I look at A, D, and E, I notice again we had the same average rate of change in all three calculations. So for question F, we can write the average rate of change is the same and it should always remain the same over any interval. And then we're given a definition. Any function in which the average rate of change between any pair of points is constant is called a linear function. Okay, so when we first looked at the table, we decided the table was a function because each input only had one output. So yes, we know the table is a function, but the question is it a linear function? The answer is yes, this is a linear function because the average rate of change is constant regardless of the ordered pairs we pick. I can pick any set of ordered pairs and the average rate of change will be constant between them. That's what makes a linear function. So when I look at question 3, it says, is the value V of the car a linear function of the number of years N of ownership? The answer is yes, because the average rates of change are constant. Then we're asked, is this function increasing, decreasing, or constant? Well, because of the negative sign, this is a decreasing function. If we had a positive sign, it would be an increasing function. That concludes this part of the lesson.